Hey, it's Mr. Allred, and we're going to talk about geometric shapes and a few of their characteristics, mostly perimeter and area. And in this video, I'll describe formulas and calculate a few perimeters and areas for common figures. The first thing to kind of kick off the bat here is perimeter. What is perimeter? If you're not familiar with it, it's the distance around the outside of a figure. If you're trying to think about this like an application, if you think like a football field or a track or a park, it would be the distance if you were to walk around the edge of it, so a distance traveled. This is a single unit in distance. Usually it's probably like feet or meters if you take the example I was using there. The other thing we'll talk about here is area. And area is the amount of space enclosed in a figure. So if you were doing your floors in your house, this would be how much material you would need, because you would cover the entire floor, not just the outside. Or if you were painting something, or if you were making a driveway, you would be filling it with concrete, and you would need a certain amount of material to cover that space, and that space is usually measured in square units, like meters cubed, meters squared, feet squared, so on. So let's jump down to a couple of problems here. First, we're going to work with circles. So it says, given the following figure of a stool seat, so like a bar stool, find the circumference. So keep in mind that if you're not familiar with the word, circumference means the same thing as perimeter. Would be the same thing as perimeter. And if you've never worked with this, the formula for circumference, which is what we call perimeter for a circle, is let me do that again. Let me give it to you in a better way. 2 pi r. And if you're not familiar with pi, it's a constant number. Up here it tells us to use 3.14 for pi. So this is not a number you have to come up with, and most of your calculators probably have a pi button on them. But for this problem it tells us to use 3.14, so we're going to do that. So pi will always be 3.14. So in doing this problem, we're just going to take the radius. That's what r stands for. R equals radius. And we're going to look in here and we're going to notice that the radius of this thing is halfway across the circle, which is 25 centimeters. So in plugging this in, our circumference will be 2 pi. So that's, I hate it when that happens. It does it when I least expect it to. So let's see if we can fix this. 2 times 3.14. And then times the radius, which was 25, and that's 25 centimeters. So I'm going to pick up a calculator and I'm going to type all this in. 2 times 3.14 times 25. And it says round to the nearest hundredth if necessary. My calculator gave me an exact number, 157, and that would be in centimeters. So based off of the circle we have here, the circle has a radius of 25 centimeters. And if we were to walk all the way around the circle that's described here, probably not walk, but put something around it, it would be 157 centimeters. So keep this handy. We have the formula for the circumference of a circle, which is 2 pi r, where pi is 3.14 and r is the radius. Alright, the next one we've got here is we've got another circle. It says, given the following figure of a magnet, so a little round magnet, how many square centimeters of paint would be required to cover the top's surface? So we're talking about how much space here. So when it says square centimeters, that's automatically taking us to a area. So the area of a circle is pi times r squared. And we can look down here and we can see the r is 12 centimeters. So this formula, pi r squared, is the area of a circle. So if you run into another circle and you need the area, this is what you're using. In this case, the r is 12. So let's just plug in and calculate. Pi, it says once again to use 3.14. And then it's going to be times 12 squared, which you may know as 144. But let's see here. 144 times 3.14. And again, it says round to the nearest hundredth. That's 2 decimal places. My calculator actually says this only has 2 decimal places. 452 and 16 hundredths, and that'll be in centimeters squared. So pi r squared is the area of a circle. Okay. Our next figure is a triangle. It says a triangular flower bed is to be created. The following figure represents the layout of the flower bed. How many feet of landscape edging would be required to outline the edge of the bed? So basically they're asking us if we were to go all the way around this thing and build like a wall or enclosure, we'd need 9 feet on one side, 12 feet on the other, so that's 21 feet, but we also need some material on this other side, so we're trying to total that up. So, and we'll give you a unique formula here. It's called the Pythagorean theorem, but it relates 3 sides of a right triangle. Okay, a squared plus b squared equals c squared. And in this case, c is the longest side, commonly known as the hypotenuse. But not just saying C is the longest side for this one, but C is always the longest side. So A and B can be either of the other 2 sides. We can describe them in either way we like. But I'm going to let A be the 9 feet and B be the 12 feet. So we're going to try and find C. So we've got a little formula here. A squared plus B squared equals C squared. So we're going to solve this. 9 squared plus 12 squared equals C squared. So do a little bit of algebra here. 9 squared is 81. 12 squared is 144, which is C squared. So we're going to add those 2 together, and I believe that gives me, well, let's use our calculator just to be careful. 81 plus 144, 225. So C squared is 225. So I'm going to take the square root of both sides, and C should be 15 if I'm not mistaken. Yes. So C is 15. So that's what we learned by this formula. So if we have a right triangle, meaning something with a 90-degree angle, and we know 2 sides, we can find the missing side. In this case, the missing side was the longest side, C. In the next example, we might be looking for a different side, so make sure you're paying attention. But then here, we need basically the perimeter. And that would be all sides added together. So 9 plus 12 plus 15 equals, 21, I believe this is 36 feet. I'm going to do that on a calculator because I'm feeling a little weird right now. Yes, 36 feet. So it says how many feet of edging to go around there, and that's what we get. Let me go back and look at something real quick. Okay, sorry. I was curious about my spelling in a previous problem. Alright, so here we have the same type of problem, except we're asked for something different. It says a triangular flower bed is to be created. The following figure represents the layout of the flower bed. How many square feet of landscaping fabric would be required to cover the surface of the bed? So maybe we're going to try and fill this thing with some type of, like, if you're familiar with it, some black gardening cloth, which when you lay it down and throw some dirt over it, it keeps weeds from growing through. So you could kind of like poke holes in it and plant your plants in there, but nothing else could come out except through those holes. So I need to give you a formula here. So I need to give you area of a triangle, which will be 1/2 base times height. Now let me draw you a figure here. We're talking about a right triangle here. So we have base and we have height, and neither one of those is the hypotenuse in this figure. Okay. So in this case, if I reposition this, just to kind of give you the orientation, it looks like what I have over here is 15 and I have 17. So I don't have the base. So in the scenario before, this could be A, this could be B, and this could be C. But basically what I've got here is the height of this thing is 15, but I don't know the base. So when I say 1/2 base times height, I need to orient that so that I have my right angle in a corner. Okay. Because if I look at this thing the way it's drawn, the height is not either one of the sides, so I can move it around to make that happen. But I'm going to use the a squared plus b squared equals c squared again. So I'll have 15 squared plus b squared, since that's the one I don't know. C is the longest side, so c squared. Let's move me up top out of the way. I'm just kind of hanging out down there, getting in the way. So let's see here. 17 squared is 289. I'm doing this a little bit backwards, but on this side, 15 squared, we just saw that number a minute ago, is 225 plus b squared. So we got to solve for b, so we got to get b by itself. So I'm going to subtract the 225 from both sides. So 289 minus 225 is 64. And the square root of 64 is 8. So what I learned here is that the base of this triangle, or the b side, is 8. So I didn't really need the hypotenuse or the longest side, outside of the fact that they didn't give me the two sides I did need, so I needed it to help me find that base. Now I need to come over here and use that in my formula. Okay, so we said the area of a triangle is 1/2 base times height. And we had to work to get our base, which was 8, and when we reoriented it, the height was 15. So I'm going to put this in the calculator. I believe it is 60, and this comes in square units, so it's 60 feet squared. Let me put it in the calculator. I feel confident. I've done this number several times. Yes. So in the end, I get that I would need 60 square feet of landscaping fabric to put in that flower bed to keep weeds from growing. Okay, we're going to do some more figures in a second, but we're going to cut this video off for time.